There is a mineral that stops window condensation permanently, costs $1 for a bag that treats every window in your house, and has been sitting in the shoe section of every retail store in the country for the past 50 years. It is the same material already installed inside every double-glazed window on the market, placed there by the manufacturer to prevent condensation between the panes. When that factory-installed material runs out, the window fogs, the seal appears to fail, and the industry tells you the entire unit must be replaced at a cost of $300 to $800 per window. The global double-glazing glass market was valued at over $26 billion in 2024. The mineral that prevents every condensation failure in that market costs $1 per bag and never wears out if properly maintained. Welcome to Forbidden Camping, where we open the vaults the industry welded shut. Let me take you back to where this story begins. Silica gel was known as early as 1640, documented as a scientific curiosity in European chemistry literature. It remained an obscure laboratory compound for nearly 3 centuries before its practical properties were recognized during the First World War. In 1918, chemistry professor Walter A. Patrick at Johns Hopkins University filed a patent for the manufacturing process that made silica gel commercially producible at scale. His patent described a material with a surface area of approximately 800 square meters per gram, meaning a single gram of this mineral contains more usable surface area than the entire floor of a large house. That enormous internal surface area is what makes silica gel so extraordinarily effective at capturing and holding water vapor. During the Second World War, the United States military used it to keep penicillin dry, protect electronic equipment from moisture damage in tropical environments, and maintain the stability of high-octane aviation fuel catalysts. By 1945, the material had proven itself in the most demanding moisture control applications the world had ever created. The physics of window condensation is simple and has been understood since the 18th century. Warm air holds more water vapor than cold air. When warm, humid air from inside a building contacts a cold surface, the air temperature drops below what physicists call the dew point, and the water vapor it was carrying precipitates as liquid water droplets on that surface. Every fogged bathroom mirror, every winter windshield, and every condensation ring left by a cold glass on a wooden table is the same physical process at work. In a double-glazed window, the 2 panes of glass create an insulated air cavity between them. That cavity contains whatever air was trapped at the time of manufacture, and that air contains some moisture. As temperatures fluctuate between seasons, that trapped moisture alternately evaporates and condenses against the colder inner glass surfaces. Without any intervention, every double-glazed window would fog permanently within its first winter. The window manufacturing industry solved this problem decades before the consumer market existed. Inside the aluminum or polymer spacer bar that runs around the perimeter of every double-glazed unit, manufacturers pack small quantities of desiccant material, almost always silica gel or molecular sieve, to absorb the moisture from the trapped air cavity. Silica gel, with its surface area of 800 square meters per gram, can hold up to 37% of its own weight in water vapor before becoming saturated. An InterNACHI technical document confirms that silica gel has approximately 7,200 square feet of surface area per gram, which allows it to absorb large amounts of water vapor from the small air cavity between 2 window panes. As long as the silica gel inside the spacer bar remains unsaturated, the air cavity stays dry and the window stays clear. The manufacturer installs just enough desiccant to handle the moisture expected over the window's design life. The condensation failure that triggers window replacement is not a structural failure of the glass. It is a desiccant saturation event. As the window seal ages over years of thermal expansion and contraction cycles, microscopic pathways develop that allow small amounts of outside air to enter the cavity. That incoming air carries humidity, and the silica gel inside the spacer bar gradually absorbs that humidity until it cannot absorb anymore. Once the silica gel is fully saturated, any additional moisture entering the cavity has nowhere to go except onto the cold glass surface as visible condensation. The window appears to have failed completely and permanently. The industry advises replacement. The actual failure mechanism is not the glass, not the frame, not the argon gas fill, and not the seal itself. It is $1 worth of silica gel that has reached its moisture capacity after years of use. The window replacement industry does not volunteer this information to consumers. The global window replacement and installation market was valued at approximately $12.5 billion in 2024 and is projected to reach $20 billion by 2033. Every fogged double-glazed window is a potential replacement sale. A homeowner told their window has failed and must be replaced at $300 to $800 per unit. Multiplied across the typical house with 20 or more windows, faces a bill of $6,000 to $16,000. The condensation problem that drove that sale began with a bag of silica gel that cost less than $1 and was never replenished. The industry that profits from window replacement units has no structural incentive to inform consumers that placing fresh silica gel near the edge of an aging window can extend its functional clarity by years without any replacement at all. The suppression operates through the architecture of how double-glazed windows are constructed and sold. The desiccant is sealed inside the spacer bar, inaccessible after manufacture. The consumer never sees it, never knows it exists, and never understands its function. When the window fogs, the entire unit appears to have undergone some complex technical failure that only a glazing professional can address. The language of window failure is framed entirely around seal failure, argon gas loss, and unit integrity, not around desiccant saturation. A consumer who understood that desiccant saturation was the primary mechanism of window fogging would logically ask why the desiccant cannot simply be replenished. The answer is that it can, but the industry prefers replacement over repair because replacement generates dramatically more revenue than a $1 bag of silica gel. Silica gel has one additional property that makes it particularly valuable for building moisture control beyond window applications. Once saturated with water vapor, it can be regenerated by heating it to approximately 120 degrees Celsius for 1 to 2 hours, releasing the absorbed moisture and restoring its full absorption capacity. A single bag of silica gel maintained properly never needs to be discarded. It can be dried and reused indefinitely. The little white packets marked "Do Not Eat" that arrive in every shoebox, every electronic device package, and every leather goods purchase contain exactly the same material. A $1 bag of silica gel beads from a craft store, a hardware store, or an online retailer contains enough material to significantly reduce condensation around a window frame for an entire heating season. Dried and recharged periodically in a low-temperature oven, that same bag serves the same function every winter for years. The practical application for condensation control on aging windows takes two forms depending on the window type and condensation location. For condensation, forming on the interior glass surface of a single pane or older window, the problem is room humidity, not window failure. Reducing interior humidity through ventilation, exhaust fans in kitchens and bathrooms, and moisture-absorbing materials near windows directly addresses the mechanism of surface condensation. Placing small mesh bags of silica gel on windowsills or between window layers absorbs the localized moisture near the glass surface and dramatically reduces the frequency and extent of condensation formation. A user on the Permies Sustainable Building Forum documented eliminating condensation on all windows except one using 3 tablespoons of silica gel beads in a small mesh bag on each windowsill throughout a winter that included nights at 22 degrees below 0 Fahrenheit. For condensation forming between the panes of a double-glazed unit where the factory desiccant has saturated, the application requires access to the cavity between the panes. A small pilot hole drilled through the spacer bar at the bottom of the window unit allows desiccant to be injected into the cavity. The interior surfaces are first cleaned and dried by injecting dry compressed air through the hole, which removes the visible condensation and the humidity carrying it. Fresh silica gel beads or molecular sieve material is then poured or blown into the cavity through the same access hole, after which the hole is sealed with a self-tapping screw and silicone sealant. This procedure costs the materials involved, which total under $10, and the time to perform it, which takes approximately 30 minutes per window. The window restoration industry charges several $100s for this same basic procedure because the consumer does not know it can be done at home. The historical record of desiccant use in buildings and structures predates modern window manufacturing by centuries. Sailors crossing the Atlantic stored sensitive navigational instruments in sealed wooden boxes packed with clay desiccant materials to prevent moisture damage. Museum conservators have used desiccant materials to control humidity in display cases since the 19th century, protecting manuscripts, textiles, and metal artifacts from moisture degradation. The Japanese traditional practice of using charcoal and dried botanical materials to regulate household humidity reflects the same fundamental understanding that moisture control is an active, manageable process rather than a permanent structural problem. Every civilization that stored valuable materials in humid environments developed some form of moisture management technology because the alternative was degradation and loss. The modern building industry reversed this understanding by designing moisture control into the window unit at manufacture and then presenting its eventual saturation as an irreparable structural failure. The silica gel available at craft stores, hardware stores, and online retailers for moisture control purposes is chemically identical to the desiccant installed in double-glazed windows by manufacturers. The indicating variety, which turns from blue or orange to pink when saturated, provides visual confirmation of when recharging is needed. Standard food-grade silica gel without color indicators is equally effective and safe for household use. A 500-gram bag of silica gel beads purchased online costs approximately $5 to $10 and contains enough material to treat dozens of windows across an entire house. Spread across windowsills in small breathable mesh bags, silica gel beads reduce the localized humidity at the glass surface that drives condensation formation. Placed in the sealed gap of secondary glazing or storm window installations, the same material prevents the interpane fogging that typically leads to complaints and removal of otherwise functional window systems. The window and glazing industry has built its consumer communications entirely around replacement as the only solution for any window problem visible enough to generate a service call. Condensation is the most common visible window problem that homeowners report. The industry response to condensation is consistently unit replacement rather than the desiccant maintenance that actually addresses the underlying mechanism. A homeowner who calls a glazier about a fogged window will not be told that a bag of silica gel and a drill bit might solve the problem. They will be shown sample units, given a replacement quote, and scheduled for installation. The information gap between what the industry knows about desiccant mechanics and what the consumer is told represents the entire business model of the window replacement service sector. That gap is worth billions of dollars annually in replacement unit sales that a $1 bag of mineral prevents. There is one accurate limitation to establish before the application method. Silica gel addresses moisture-driven condensation, which is the overwhelming majority of window fogging cases. It does not address condensation caused by actual glass breakage, failed seals that admit bulk liquid water rather than vapor, or structural window failures involving the frame or sash. If condensation appears immediately after installation of a new window, or develops in isolated spots suggesting physical damage, professional assessment is appropriate. For the standard case of a window that cleared well for years and then began fogging gradually over 1 or 2 winters, desiccant saturation is the primary cause in the overwhelming majority of cases, and fresh desiccant is the appropriate first response before any replacement is considered. The $30 assessment call to a glazier and the 30-minute drill and fill procedure produce the same diagnostic conclusion in nearly every standard condensation case. Silica gel was known in 1640, weaponized in gas mask canisters in 1918, used to protect penicillin during the Second World War, and installed inside every double-glazed window manufactured since the 1950s. It has been sitting in shoe boxes and electronics packages in every home in the developed world for the past 70 years, marked with warnings not to eat it and discarded into landfill by the billions of units. The same material that the window manufacturing industry pays suppliers to pack into spacer bars at fractions of a cent per gram is available to any consumer for $1 at any craft store in the world. The $26 billion double glazing market and the $12 billion window replacement market both depend on the consumer never connecting the fogged window in their living room to the small white packet they threw away when they opened their last pair of shoes. Subscribe and share this video because every share is one more homeowner who opens that shoebox packet and puts it on a windowsill instead of in the trash. The next vault opens soon.